Alan Lightman, Martin Rees. The Shape of Wonder. How Scientists Think, Work, and Live. Every time you switch on a light, start your car, or scroll through your phone, you're surrounded by the quiet marvels of human curiosity and creativity. Science and technology are so tightly woven into daily life that it's easy to forget how recently many of these innovations appeared. Just a century ago, cars, computers, televisions, and refrigerators either didn't exist or were barely imagined. Yet all of them sprang from the same impulse that has driven humans for millennia: wonder. The desire to make sense of the world, to understand patterns in nature, and to uncover our place in the vast cosmos. But science isn't just a collection of facts or artifacts. It's a way of thinking and moving through the world. It thrives on curiosity, disciplined inquiry, and collaboration. Individual scientists bring creativity, persistence, and emotional investment, while the wider scientific community ensures that each new idea is tested, critiqued, and refined. Contrary to external perceptions, progress rarely happens in dramatic leaps. It comes step by step, with small discoveries building to a larger understanding. In this blink, you'll learn what draws people to science and how they become scientists. You'll discover how scientific thinking works, how scientists spend their days and take responsibility for their work, and what keeps them motivated through years of effort and uncertainty. By exploring these patterns, you'll see science not as an abstract pursuit, but as a profoundly human endeavor, one that shapes our world, propels our understanding, and reflects our innate human capacity for wonder. Origins. We're surrounded by everyday miracles that only exist because someone, at some point, asked a question and refused to let it go. The conveniences we now take for granted, from devices to drugs, are all products of this relentless curiosity. Yet each one can be traced back to a simple impulse as old as humanity itself: the urge to make sense of the world and to bring a little order to its mysteries. What makes this especially remarkable is how far we've managed to get. With just a few pounds of neurons inside our heads, humans have mapped galaxies, probed the depths of atoms, and uncovered forces that govern the entire cosmos. None of this was inevitable. It happened because, generation after generation, people chose to wonder. Or, in other words, because people chose to become scientists. There isn't one road into science, however. Some grow up in households where science is a constant presence, while others discover it in school with no prior exposure at all. For some, the path begins in comfort and opportunity. For others, in struggle and hardship. Yet despite these differences, a few common threads appear again and again: curiosity, an independent mind, and persistence. Often the spark shows up early: a child dismantling gadgets to see how they work, a young stargazer enchanted by the night sky, or a kid struck by the elegance of numbers. Just as often, all it takes is a teacher's encouragement or a parent's nudge at the right moment for a passing interest to turn into a lifelong pursuit. Independence of thought also matters. Many future scientists are drawn less to following instructions and more to charting their own course, learning by exploration rather than prescription. But beginnings aren't always so straightforward. Competition and ambition can propel some into the field. Others arrive later in life, discovering their passion not through equations or experiments, but through a life experience that unexpectedly captures their attention. And for those who grew up in adversity, science can become a way to push back against limitation, a path forged out of determination to understand and overcome the challenges around them. In sum, there is no single origin of species when it comes to scientists. The common denominator isn't background or circumstance, but rather the willingness to ask questions and pursue them with tenacity. However the journey begins, scientists find themselves on a shared path, one defined by wonder, resilience, and the drive to uncover what lies beyond the horizon. Thinking like a scientist. Curiosity may light the spark, but what sets scientists apart is how they use it. They don't just marvel at the world. They train themselves to test ideas against reality, constantly asking whether what they believe holds up when measured, observed, or challenged. This way of thinking isn't about memorizing facts, but about developing habits of questioning, testing, and revising. At its best, it's a disciplined form of their initial childlike wonder. Underpinning the scientific approach lie two implicit assumptions. The first is that there's an objective world outside our minds. The second is that this world behaves in consistent, discoverable ways. From those foundations grows an entire method of investigation. Observe, hypothesize, test, refine, repeat. It's not a rigid formula, but an evolving toolkit, ever adapting to new questions and new evidence. What often surprises non-scientists is just how provisional even the strongest theories are. A scientific theory isn't a casual guess. It's a carefully built framework, grounded in evidence, that can explain broad phenomena and make predictions that can be tested. Yet, no matter how elegant, a theory must always remain open to revision. Tomorrow's experiment could reveal a detail that reshapes the whole landscape. But this willingness to change isn't a weakness. It's the very engine that keeps science alive. Still, this openness can create misunderstandings. When the public sees scientific consensus shift on nutrition, the climate, or technology, for example, many take it as proof that scientists can't be trusted. In reality, those revisions are signs of strength, showing a system of knowledge that corrects itself rather than clinging to dogma. Science advances not by claiming certainty, but by constantly sharpening its picture of the world. Of course, scientists are human, and that complicates things. An individual researcher may fall in love with a theory they've invested years in, overlooking evidence that contradicts it. Pride, ego, and ambition can cloud judgment, as they can in any profession. But here, the scientific community comes into play. Science is built on critique. Peers interrogate methods, challenge equations, and demand results that can be reproduced. This shared scrutiny doesn't erase individual bias, but it helps foster accountability within scientific innovation. In the end, scientific thinking is both deeply personal and profoundly communal. It asks individuals to bring imagination, persistence, and emotional commitment, while relying on a wider community to test, question, and refine their ideas. Together, they sustain a way of thinking that has allowed us, fragile and fleeting as we are, to map galaxies, split atoms, and elevate our experience of the world around us. Working like a scientist. Nearly 9 million people today carry the title of scientist, yet rarely is their daily work as dramatic as the breakthroughs splashed across headlines. Ask one what they're focused on, and you probably won't hear ridding the world of chronic disease or mastering the theory of everything. Instead, they'll likely describe a single protein structure or a stubborn equation. For the most part, science advances this way: through small, careful steps that gradually build into something larger. The beauty is that these fragments don't stay isolated. Over time, they melt into the shared body of knowledge in which the original author almost disappears. For instance, if Einstein hadn't proposed the theory of special relativity, someone else almost certainly would have within a few years. This contrasts with the arts, where the original author remains closely tied to their work. The probability of someone other than Beethoven composing his Ninth Symphony is essentially zero. Science is cumulative and reproducible in a way that art is not, which makes each edition, however modest, part of a much larger whole. That cumulative nature also sets the rules of the game. A classical pianist can choose whether or not to reference Beethoven in a new composition. A physicist, on the other hand, must ensure any new theory fits with Einstein's theory of special relativity, or explain why it doesn't under extreme conditions. By its nature, scientific knowledge builds on what came before, demanding continuity, coherence, and accountability across generations. Yet the work of scientists isn't confined to the field or lab. It also carries profound responsibility in the wider world. Discoveries and technologies don't arrive preloaded with values of right or wrong. They are neutral tools until humans decide how to use them, for better or for worse. As a result, scientists, as responsible citizens, need to burst the comfortable bubble of open-ended theorizing or contained experimentation. They need to engage with the public, with policymakers, and with the media, ensuring their findings are used wisely and communicated carefully. Misinterpretations can spread easily, so clarity matters as much as precision, and humility as much as ambition. Because science, for all its reach, does have boundaries. It can tell us how a gene works or how the climate changes, but it can't answer what is just, beautiful, or meaningful. Recognizing those limits isn't a flaw. It's part of what keeps science honest. Yet within its scope, the work of scientists continues to shape daily life, one careful step at a time, weaving individual efforts into humanity's collective pursuit of understanding. Sustenance. So we have an idea of what draws scientists to science, how they think, and how they work. But what keeps scientists at their benches, laptops, or telescopes year after year? The answer isn't simple, because the motivations are as varied as the people themselves. Unsurprisingly, curiosity is perhaps the most universal driver, the primal urge to understand the strange cosmos we inhabit. But curiosity alone rarely sustains decades of patient work. What carries scientists forward is a mix of ambition, competition, creativity, and the sheer joy of discovery. Progress in science is usually incremental. Most breakthroughs come not as sudden flashes of brilliance, but through long stretches of trial, error, and sheer determination. However, even small advances can provide enough satisfaction to keep someone going. A pattern recognized, an experiment that finally works, two ideas that suddenly connect. The thrill of these moments may be brief, but it's powerful enough to fuel years of effort in pursuit of the next one. There's also a craftsmanship to science that outsiders sometimes overlook. For some, the pleasure lies in designing new instruments, building the tools that will make future discoveries possible. For others, it's the elegance of a solved equation or the clarity that comes when a solution finally clicks into place. The process itself can be deeply rewarding, independent of a grand breakthrough. Of course, more personal forces play a role too. The adrenaline of competition, the push of rivalry, and the pull of ego all find a place in the lab and field. Scientists are human, and ambition often accompanies pioneering innovation. But in science, ambition comes with a unique twist: the chance to add something permanent to humanity's shared knowledge. While fame may fade and names may be forgotten, the truths uncovered endure. To engrave even a single line in the collective book of understanding is a powerful incentive. There's also a broader horizon that inspires many. Astronomers remind us that the universe ahead is as vast as the universe behind, perhaps infinitely so. We, alive today, are not the final chapter of evolution, but a scene in an ongoing story. In that light, every discovery is more than personal achievement. It's a thread woven into a tapestry that will stretch far beyond us. This melting point of motivations, curiosity, ambition, creativity, rivalry, and the hope of a lasting legacy, can explain why scientists persist through long hours and frequent setbacks. They're not only chasing answers to questions, but also participating in something larger: the beauty and necessity of human wonder. In this Blink to the Shape of Wonder by Alan Lightman and Martin Rees, you've learned that wonder is what transforms our questions into inevitable discoveries, and the shape of wonder is informed in equal parts by curiosity, persistence, and collaboration. The human desire to understand the universe, whether through careful observation, playful experiments, or the crafting of new tools, has driven knowledge forward across generations. Science has succeeded not because its practitioners are flawless, but because its communities challenge, test, and build on one another's work. This creates a self-correcting system that grows stronger over time. What makes this pursuit remarkable is its universality. The truths uncovered belong to everyone, not just one person, culture, or era. Every experiment, insight, and small step adds to a shared human legacy of understanding. Even amid setbacks, rivalry, and uncertainty, the drive to know endures, revealing not only the workings of the cosmos, but also the creativity, resilience, and wonder that define us. Knowledge grows, and with it, so does the human spirit. Okay, that's it for this Blink. We hope you enjoyed it. If you can, please take the time to leave us a rating. We always appreciate your feedback. See you in the next Blink.